Chapter 4, Section 3, problem similar to what you run into in problems 19 through 28 in the book. Our definition of the log is that the log base a of b is c is equivalent to b is equal to a to the c power. A consequence of this is that the log base a of a to the k is equal to k. That means that if we can imagine what is on the inside as being the base to a power, we can solve the logarithm. We can evaluate the logarithm. In this case, remember that 1 is going to be the same as 10 to the 0. So this is the log base 10 of 10 to the 0th power, which by this rule is equal to 0. It's worth noting that the log base any number of 1 is always going to be 0. If I have the log base 2 of 16, that will be the log base 2 of 2 to the 4th power. The log base 2 of 2 to the 4th will equal 4. If I have the log base 3 of 1/27th, 27 is a power of 3. I can think of this as the log base 3 of either 1 over 3 cubed, or better, as 3 to the negative 3 power. To get the number in the denominator, you just apply a negative exponent. So the log base 3 of 3 to the negative 3 should equal negative 3. The next two require a little bit more imagination. You have to think of 2 as a power of 4. What you need to realize is that the square root of 4 is equal to 2. But with logarithms, instead of thinking of the square root, you're better off thinking of the 1/2 power. The 1/2 power is the same as the square root. The 1/3 power is the same as the cube root. So this will be the log base 4 of 4 to the 1/2. Now the log base 4 of 4 to the 1/2 will equal 1/2. The log base 2 of 0.25. If you render this as a fraction instead of a decimal, 0.25 is the same as 1/4. Now this problem looks like this problem. 1/4 is going to be 2 to the negative 2. And the log base 2 of 2 to the negative 2 will be a negative 2.